Morning, Mr. Lewis.
Good morning, Mr. Miller.
Welcome to video number 45. Today, we got factors, primes, and perfect squares.
Okay.
Mr. Lewis, can you think of anything to add to that?
No, I think that's enough.
All right. I always say this will be 5 minutes.
And it turns out to be 10.
But it'll be fine. Come on, we can do this. So we're going to create factor tables for the following numbers. So this is kind of a review skill.
Okay.
But the real important thing is at the bottom to understand what prime numbers are, composite numbers, and perfect squares are. So that's kind of the learning goal. And this won't take long. So we're going to start with a T-chart. There's kind of a lot of ways to do this. We're going to start with 30. And we're going to kind of systematically write down the factor pairs.
Okay.
So you know what we always start with?
1.
Yep.
And the number.
And the number. So we always have at least one row in there.
All right.
So 1 times 30 is 30. And then we can just go up. We
2.
see there's 2. Yeah.
2 and 15.
And then we say, can 30 be divided by 3?
Yep.
3 and
10.
how about 4?
No.
5?
Yeah.
Now, 5 and
6.
6. And we keep going. We just keep testing the numbers. 1, 2, 3. 4 wasn't. 5. But we should know when to stop.
Well, you stop when you loop back around.
Yeah.
So
if I went to 6, I already have 6.
Right.
Okay. There's another rule too. We'll see if we come up. So there's another way to find out, but that's good. So we stop when we start getting repeats. All right, 17.
1.
And 17.
And
how about 2?
I'm thinking that's it.
So you could try. So what you're doing is you're using your calculator. You go 17 divided by 2, you get a decimal.
Yeah.
17 divided by 3,
Decimal.
17 divided by 4. Turns out you can stop at the square root of the number. All right, before you get to the square root. So square root of 17 is about 4 point something. Okay, we didn't bring a calculator. Yeah. So about 4.1 or something like that. So when I get to 4, I know I can stop.
Huh.
All right, so that's another stopping rule. You can give up when you get to the whole number below the square root. All right, so 2, 3, and 4 don't work, so we're done there. All right, 48. Here we go.
1 and 48.
Got it?
2 and 24.
Is it true you used to jump rope and do this?
No.
Oh, all right.
A lot of myths going on around me.
How about 3?
Yeah, 3 and 16.
Ooh, he's good. 4?
4 and 12.
Yeah. 5?
That doesn't end in a 0 or a 5, so I'm going to say no.
6?
On the 5. 6, yeah. I think 6 and 8.
7?
7, nope. That would be 49.
Right. So, and the square root of 48 is like 6.999 something, or 6.9 something. It's
Right.
before 7. So we know we could end at 6. All right, 16. Here we go, Mr. Lewis.
All right. 1 and 16.
Yeah.
2 and 8.
Right?
No 3.
Yeah, because 16 divided by 3 is decimal.
And then we have a 4
Yes.
and 4.
So how many factors does this number have?
5.
Yep, you gotta be careful. One's repeated there. So 48 has a lot of factors. It has 10 factors, right? This only has 5 because 4 is listed twice. All right. So of these 4 numbers, which numbers are prime?
Well, prime would be just numbers that can be only divided by 1 in itself, so that would be 17.
Right. So one way to think about it is they have exactly 2 factors. So 17. I'm gonna put a little note over here. 1 is not prime.
Right.
Because 1 only has 1 factor. 1 is 1 times 1. So prime numbers are numbers that have exactly 2 factors, 1 in itself.
Correct.
2 distinct numbers. All right. How about so that one's 17. How about composite?
Well, that would be the rest of them. So 30, 48, and 16.
Yep.
Because those have multiple factors.
Right. More than 2. All right. So which numbers are perfect squares?
Well, perfect square is when I can multiply this number by itself and get that number. So that would be 16. 4 and 4 makes 16.
Yeah, if it has repeated factors. So like 16 is 4 times 4, which is 4 squared.
Yep.
So 16 is a perfect number. It can be written as a whole number squared. Mr. Lewis, you get an A+. All right. We're going to crank these out real fast. Stick to my 5-minute rule.
Okay.
What we got?
1 and 51.
Right?
No 2, 3 and 17.
Right?
And I think that's it.
Yeah. Square root of 51 is like 7 point something. So if you're trying numbers, you could go up to 7 and call it quits. Mm-hmm. By the time you made 7, you know you got it out of them all. 21.
Okay. 1 and 21.
Yeah.
3 and 7.
Yeah.
All right. 64.
Oh, here we go.
1 and 64.
Yeah.
232.
Yeah.
No 3, 4 and 16.
Yeah.
No 5, no 6, no 7, 8 and 8.
Cool. 41.
I think it's just 1 and 41.
What's the highest number you would try?
6.
Good. The square root of 41 is a little bit more than 6. So
Right.
you know you're done. We're going to 6. One reason why I like factor tables is it helps you find all the factors. It's very kind of efficiently. And they come in pairs. These are factor pairs.
Yeah, and they're a lot easier to look at than doing like the prime factor tree.
Yeah. I mean, that's useful for many things. But this one, they come in pairs. You get them all.
Right.
You feel all good. All right. Which numbers are prime?
Just 41.
Yep. Which numbers are composite?
The other 3.
And 64, perfect square? Did we have one?
64, 8 and 8.
So 64 is 8 times 8, which is 8 square.
Yeah, and remember when they ask you the perfect square to put 64, not 8.
Right, 64 is the perfect square.
Right.
8 is what you square together.
Yeah, a lot of people like, oh, well, like, we know that's what you're saying, but that's not always what's put on the
I
paper.
don't talk to those people. Man. Do you?
No.
Okay, all right. There you go. Create factor trees for the following numbers. You got 5 to do. And then tell us which numbers are prime, which are composite, which are perfect squares.
Sounds easy to me.
All right, awesome.
All right.